All right, good afternoon, folks, and welcome to a combined lesson two and three. We're going to be lesson three is dealing with the sine and cosine ratios, and lesson two deals specifically with the tangent ratio. So I'm just going to crunch them up together because they are essentially the same thing. We're just looking at different pieces of the triangle. The method remains the exact same, it's just using different sides. So, starting off with the tangent, or the first thing we want to start with is actually labeling triangles. And we saw with the first lesson that there is labeling triangles. Like if I have this triangle here, and we'll say this is A, B, C, we could label the triangle as A, B, C, like so. And remember, when we're given a right angled triangle like this, we want to label where the hypotenuse is so we can identify our Pythagorean theorem, which would be b squared is equal to c squared plus a squared in this case. Leg squared plus leg squared is hypotenuse squared. However, we actually need to go one step further and identify the opposite and adjacent sides to what is called a reference angle. Now, a reference angle could be something that is given to you in a question. We could say that A in this case is 68 degrees. That would be an indication of a reference angle. It could be as simple as having an arc like that on one of the two acute angles, acute being this one or this one, not the 90. It could also say, all right, well, find I don't know, find angle A or something like that, okay? That's indicating that we are using A as our reference angle. It could also be B, but it should be noted that, or sorry, it could also be C, but it should be noted that the right angle is never going to be a reference angle, okay? It's always going to be one of the two acute angles. So the method for identifying the reference angle, let's say we go reference angle is angle A. Okay, we'll just indicate that with a little arc like that. The way that you identify the reference angle is the exact same as identifying the hypotenuse. You just draw an arrow directly from, or sorry, labeling the sides with respect to the reference angle is the same as the hypotenuse. You draw an arrow directly out of the reference angle to the opposite side, and I just said it, that side is what is called your opposite side, or OPP. Okay, by process of elimination, remember that there's three types of sides. There's your opposite, adjacent, and hypotenuse. Um, by process of elimination, we have hypotenuse and opposite. That makes C our adjacent side. Now, where this gets a little tricky is if we take that same triangle, it's probably not going to be the same triangle, it's close enough. Let's say we have A, B, C, and we're going to change the reference angle to angle C. Okay, well, our hypotenuse doesn't change. Okay, let's see, that's A. The hypotenuse doesn't change because it's always opposite the 90 degree. What changes is now our reference angle is angle C. So drawing the arrow straight from the corner like that would give our opposite side to angle C, and by process of elimination, adjacent would be A. Okay, so notice that the things that change are the opposites and the adjacents. The hypotenuse don't change, or doesn't change. The hypotenuse? Noose? I don't know. The hypotenuse doesn't change. The opposite and the adjacent sides switch depending on your reference angle. So it's super important to identify your reference angle and use it to identify your opposite and adjacent. This step here, ooh, that's a big bold one. That step is the most critical step of the entire problem. Once you have that, you can identify which trig ratio to use and then solve from there. But if you do this first step wrong or you don't label it properly, the rest of the problem is out the window. Okay, so make sure you're 100% on how to do that. Now, since we're combining lessons 2 and 3 together, we're going to combine both the tangent, sine, and cosine ratios together. And on your formula sheet, you'll notice that tan of A is equal to opposite over adjacent. Cosine of A is adjacent over hypotenuse. I did these backwards. Oops. And sine of A is equal to opposite over hypotenuse. Okay, now please don't call it cos and sin. It's cosine and sine. Don't be lazy. Say the extra syllable. It's not going to kill you. Okay, so the tangent, cosine, and sine ratios are given there. They're on your formula sheet. The only thing you need to be able to do is label your triangles. So let's say, for example, we have that 3, 4, 5 triangle that we had before. This is 3, this is 4, this is 5. And we'll go A, B, C, right angle. This is A, this is C, this is B. Okay, let's say we've identified our reference angle here as A. So our hypotenuse here would be B. Our reference angle is A, so that's our opposite side. And by process of elimination, that becomes our adjacent side. Now, if we were to write out what the tangent, cosine, and sine ratios of these things are, all you would do for tangent is you would use your opposite number and your adjacent number and write them as a fraction. So opposite is 4, adjacent is, I'll go one step back. Okay, in this case, our opposite side is A, our adjacent side is C. So we can label it like that. We can write it as a fraction, 4 over 3, or we can write it as a decimal to 4 decimal places, 1.3 repeating. Okay, this here is your tangent ratio. Okay, the tangent ratio is just a fraction. That's all it is. Okay, we're not looking for the A in this case. We're not looking for the angle. We are looking for the tangent ratio. We'll get to the angles in a little bit. All right. All we're looking for is that fraction and as a decimal. Doing the same thing for cosine. Cosine is adjacent over hypotenuse. So our adjacent side is C. Our hypotenuse is B. Writing in the numbers. Okay. Writing in the numbers, our C is 3 and our B is 5. So 3 over 5 is 0.6. And same thing for sine. Our opposite side is A, and our hypotenuse is B. So that would be 4 over 5, or 0.8000, like so. Okay, that is the 3 trig ratios for a given triangle. Notice that we just started by labeling the triangle. As soon as we've labeled the triangle, it's just a matter of plugging into the formula. That's all it is. Okay? And remember, you're going to be asked this question. I can guarantee it. This is your trig ratio. Whether it's tan, cos, or sine, that is your trig ratio. Plain and simple. Okay? Don't forget those. Now, because you're not always going to have a formula with you, there is a simple acronym that you can use to help you remember what the trig ratios are, and it involves the first letter of each of them. So, because like I said, I wrote them upside down. It should go sine, cos, tan rather than tan, cos, sine. But if we start with I want that a little smaller. Actually, I'm going to go like this. So if we want the first letter in each of them, we get S, O, H, and then the first letter in cos, C, A, H, and the first letters in tan, T, O, A. You get the acronym SOHCAHTOA. Okay, SOHCAHTOA means sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That is what it means. That's the most useful acronym I can think of. If you look in the notes, there's a whole bunch of There's a whole bunch of other acronyms that you can use. I find SOHCAHTOA to be the most useful, but it's entirely up to you how you remember it. Just remember that the way the order goes. Now, let's put some rubber on the road and actually use these ratios to solve some problems. So we'll start with a triangle here, like so. We are going to call this ABC. We've got little a is unknown. We've got this side is 23.0 centimeters, and we have that this angle here is 28 degrees. So what we want to do to start with is you start by identifying or labeling your triangle. So that is our hypotenuse. You'll notice that A is given to us. Okay, A is given to us as 28 degrees, so that makes it our reference angle. Therefore, we have the opposite, and this is the adjacent side by process of elimination. Now, if you notice, we have opposite is what we're looking for, and adjacent is what we have. Opposite and adjacent, TOA, is tangent. So you start with tangent of your reference angle is equal to opposite over adjacent. There's a mark right in your formula. Okay, then you substitute. Okay, we know that reference angle A is 28 degrees. And it gives you opposite, which is little a over adjacent, 23.0 centimeters, like so. And then we just got to do a little bit of algebra. Okay, so we're going to multiply both sides because we're dividing a by 23. We're looking for a. We have to multiply by 23 centimeters, 23.0 centimeters, like so. Okay, so that cancels the 23 and the 23 over there. So we get a then equal to 23.0 centimeters times the tangent of 28 degrees. Now, something that should be noted here, because we are dealing with angles and stuff like that, we have to make sure our calculators are in the proper mode. Okay, we're dealing with degrees on this, so make sure your calculator is in degree mode. If you're not sure how to set it in degree mode, come ask me. I'm more than happy to walk you through that. Now, if we were to break this down into two steps, I'm not going to do this for every single one of them because I just want to make sure that your calculator is in the right mode. I'm going to calculate tan of 28 degrees. It's 23 centimeters times tan of 28 degrees. If you type in your calculator, tan of 28 should give you 0.531709 to 6 decimal places. And then if we multiply that by 23 and round to the nearest tenth, it should give you 12.2 centimeters, like so. Okay, now on this problem, that step is just extraneous. You don't need it. I'm just showing it to illustrate the point. If you want to write that, you can, but make sure you keep lots of decimal places so that you don't get any rounding issues. But yeah, that's how you solve these problems. Like I said, once you get the triangle labeled, it's really straightforward. So next one, we'll do another one. It'll work out to be another tangent one, but we'll work with it. So we're going to go C, D, E, like so. We're looking for little e. We know that C is 16 centimeters, like so, and we know that little c is 44, or big C, sorry, is 44 degrees. So, same thing as before, start with your hypotenuse. Okay, label it. Hypotenuse is there, and C is our reference angle, so that would be our opposite. This would be our adjacent. Now, if you notice, we have the opposite, and by the little e that we have there, we are looking for the adjacent. So opposite and adjacent, same as before, tangent. So we would go then tangent of a reference angle. C is equal to opposite over adjacent. You could go for another step here and actually throw in the little letters. Our opposite side is C and our adjacent is E. You could do that. You don't have to though. And then substituting the numbers in, we get tangent of 44 degrees is equal to our opposite side of 16 centimeters over our adjacent side of E. And if you notice this time, our E is on the bottom. Okay. Remember, we don't like having e's on the bottom, the variables on the bottom, unknowns on the bottom of the fraction. So we got to get it up onto the top of the fraction. To do that, multiply both sides by e. Okay, in this case, the e and the e will cancel, and you get e tan of 44 degrees equal to 16 centimeters. Okay, now to get the e by itself, we have to divide both sides by tan of 44 degrees. Just keep the tan 44 all together. Remember, tan is just an operator. It applies to the 44 to give you a different number. So keep it all together. And tan 44 over tan 44 can divide to give you 1. So you'll end up with e equal to 16 centimeters over the tan of 44 degrees, like so. Putting that in your calculator, you should end up with 16.6 centimeters, like so. Okay, that's a different example of how to use your tangent, depending on how it lines up. So we'll go through and do a couple of cosine and sine ratio ones. Yeah, okay. So we'll start with another triangle, like so. I want a little thing there. We're going to call this thing RSQ. S, we're going to be given 28 degrees. We don't know what little s is, and we know that is 9.6 meters there. So same thing as before. You're starting with a triangle, label it. Okay. That's our hypotenuse. Reference angle is S. So that is our opposite side, which makes this our adjacent side. Now we're dealing with, or we have the hypotenuse and we're looking for the opposite. Opposite and hypotenuse is sine. So, right? So sine of our reference angle S is equal to opposite over hypotenuse. Substituting in our numbers, sine of 28 degrees is equal to our opposite side, little s, over our hypotenuse of 9.6 meters. Again, we have to get the s by itself, so you multiply both sides by 9.6 meters. And that gives you s equal to 9.6 meters times the sine of 28 degrees. Okay. Plug it into your calculator, it should give you 4.5 meters, like so. Okay, another one. Notice that the steps remain the exact same. We're just changing the formula. We're just depending on the reference angle. So we have a right angle there with, this is M, this is J, this is K. All right, we're given J is 39 degrees. And we're given this side here is 17.4 meters. So same thing as before, start by labeling your triangle. This is your hypotenuse. Oh, sorry, I forgot to add. We're looking for that guy there. Okay, we're looking for M, little m. So that's the hypotenuse. The reference angle is given to us as J. So draw your arrow across like that. Which makes this your opposite side, and by process of elimination, that is your adjacent. So we're dealing with, we have the opposite, we're looking for the hypotenuse, we're dealing with sine again. So sine of J is equal to opposite over hypotenuse. Start with the formula always. So then sine of 39 degrees, whoa, 390 apparently, 39 degrees is equal to our opposite side, 17.4 meters over our hypotenuse M. Would you look at that? We're dealing with M on the bottom again. So then M sine 39 degrees, just not showing my algebra, 17.4 meters, which gives me M then equal to 17.4 meters divided by the sine of 39 degrees, 390 again, which gives you m equal to 27.6 meters. Okay, which makes sense. We're looking for a long side there because it's the hypotenuse. All right, a couple more. Start with the triangle again. We're going to call this one an ABC triangle, like so. We're going to look for little c, and this is going to be 15.6 meters. So, I forgot, B is 40 degrees. So, starting off again, label your triangle. Okay. This would be our hypotenuse. This would be our opposite side. So by process of elimination, this is our adjacent side. Now we're looking for we have the hypotenuse and we're looking for the adjacent. So adjacent and hypotenuse, K is cosine of B equal to adjacent over hypotenuse, like so. So then cosine of our B, which is 40 degrees, is equal to our adjacent side C over our hypotenuse, 15.6 meters. Okay, again, we're looking for C. So C is equal to 15.6 meters times the cosine of 40 degrees, which gives us a C equal to 12.0 meters. Like so. Okay, it's like I said, it's the exact same process. We're just using different numbers, different triangles, and a resulting different formula. So another triangle. This one's going to be an RSQ again. Okay. We've got little r is 11.9 centimeters, and we're given S is 29 degrees, and we are looking for little q. So, same thing, label the triangle. Hypotenuse, opposite, adjacent. So, we have the adjacent side, we're looking for the hypotenuse, so cosine of S is equal to adjacent over the hypotenuse. So cosine of 29, oh, that doesn't look like a C. I'm going to fix that. It's terrible. Cosine of 29 degrees is equal to our adjacent side, 11.9 centimeters, over our hypotenuse Q, like so. So same thing as before. Q, oh, come on. Q cos 29 degrees. That was strange. Not sure why it did that. Okay, interesting. I'll go back down to the bottom. There we go. So Q cos of 29 degrees is equal to 11.9 centimeters. Dividing both sides by cos 29, Q is equal to 11.9 centimeters over the cosine of 29 degrees, which gives us Q equal to 13.6 centimeters, like so. Okay, now last thing about these is determining angles using sides. It's a little tricky. It's a little bit to wrap your head around, but it's not too bad once you figure it out. So, if I said that x plus 4 is equal to 5, we could figure out what x is by doing a little bit of algebra. Subtract 4 from both sides would give me x is equal to 1. Okay. If I were to say 2x is equal to 5, again, I could figure out what x is by dividing both sides by 2 to give me x is equal to 5 halves, or 2.5. If I had x squared is equal to 5, okay, I could figure out what x is by taking the square root of both sides. So x then is the square root of 5, or 2.236, on and on and on. Okay. Notice that for each of these mathematical operations, addition, multiplication, exponents, I am doing an inverse operation to cancel it. So I'm subtracting to cancel an addition. I'm dividing to cancel a multiplication. I'm square rooting to get rid of a square, cube root to get rid of a cube. I said earlier, the trig functions are operators just like everything else, which means there is an inverse. Because if we look at it this way, if we say tan of A is equal to, I don't know, 5 over 7, something like that, okay? If tan of A is 5 over 7, and we want to find what the angle is, we can do the inverse operation of, because this is tan of A. This is not just A, this is the tangent of A, tangent ratio. So we can do the inverse of that to figure out what A is, to cancel the tan from the A. And the way we do this is what's called the inverse tangent, and it looks something like this. Okay, it's just tan to the power of -1. That's all it is. Writing that out then, we get, tan inverse and tan cancels. It's the same thing as multiplying and dividing. It's adding and subtracting. It's square and square root. They cancel. The purpose then is we are left with A on this side. So A then is the inverse tangent of 5 over 7. And if you look on your calculator directly above the tangent button, depending in your second function color, whether it's blue or yellow or orange or whatever it is tan -1. This is right above that button. So you press second function, or if you're using a scientific calculator, there's different buttons. Anyways, second function or your alternate function button, and then you type 5 divided by 7, and it should give you 35.5. Now in this case, what we found was a reference angle. Angles have units. They are degrees. So this would be 35.5 degrees for this case. You have to label it with the angle. Now, a couple of examples. We'll do 3 examples, one of each sine, cosine, tan. If, let's say, we have that triangle right there. I don't like that. That's not working good. I want to move it down a little bit so that I can get out of my way. All right, triangle. Right angle triangle. I'm going to say this is 9 and this is, I will say 16, I guess. And this is going to be A, B, C. And I'm going to put a little arc like that. Okay, that little arc means that is our reference angle. So, labeling our triangle, that is our hypotenuse, that is our opposite, this is our adjacent. Okay, we have the opposite side, we have the hypotenuse side. We are looking for angle C. So, opposite and hypotenuse is sine of C is equal to opposite over hypotenuse. Start in the same place every single time. Start with your formula and then substitute what you know. Sine of C is equal to our opposite side over our hypotenuse. And then we want to get C by itself. We want to figure out what angle C is. So do the oops, I want my green pen back. Do the inverse sine of both sides, like that, which would leave you with C is the inverse sine of 9 over 16, like that. Okay, plugging that in your calculator, oops, would give you 34.2 degrees to the nearest tenth. Okay. Now, we'll do another one just to illustrate the point. This is going to be DEF, right angle. I'm going to say this one is 35. This one here is, we'll make it something ludicrous. We'll make it 3. And our reference angle is going to be F. Same thing as before. That's our hypotenuse. That is our opposite, which makes this our adjacent. Okay, start by labeling. Now, we have the hypotenuse, we have the adjacent, we're looking for the angle. So, Oh, brain fart. Sorry. We have the hypotenuse and we have the adjacent looking for the angle. Opposite or adjacent and hypotenuse is cosine. So cosine f is equal to adjacent over hypotenuse. So cosine of f, we don't know what f is equal to 3 over 35. So then f is the inverse cosine of 3 over 35, which is equal to 85.1 degrees. Okay, another one. Whoops. There we go. F, we'll go G, H, J. This I is a terrible letter for mathematical purposes. Capital I, anyways. So GHJ is our triangle. There's our right angle. And I'm going to say that this is 15 and this is 8. Okay. And I'm looking for angle G. Same as before. That's our hypotenuse. That is our opposite, which makes this our adjacent. So we have the adjacent, we have the opposite, we're looking for the reference angle. So that opposite and adjacent is tangent of G is equal to opposite over adjacent. So tangent of G, we don't know what G is, so just leave it as G, is equal to the opposite side over the adjacent side. So G then is the inverse tangent of 8 over 15, which is 28.1 degrees, like so. Okay, that's sine, cosine, tan. That's really all there is to it. Big takeaways from this one is this right here. Label it. If you label it every time, you get good at labeling it. It makes it so much easier to be able to pick the right trig ratio, to be able to solve the problems easier. It all comes down to labeling that triangle. Just remember, 3-mark questions. Start with the formula, substitute into the formula, and get your answer. Okay. If you have any questions, same as always, let me know. We'll be moving on to solving triangles and multiple triangles after this.